Hello, good day everyone. Welcome to Hi-Fi Tech Group and welcome to our CCNA course ICND 1 and 2 200-1 to 5. My name is Irfan Haq. This is the third video for CCNA ICND 1 and 2. In our first video, we have taken you through the course outline. There are 13 sections in the new CCNA course. We have discussed introduction to networking in our last lecture. So we discuss about the OSI layers and how it is different from TCP/IP layer and the purpose of each and every layer and how the data is transported when it moves from one layer to other layer. And today lecture is about fundamental of Ethernet LAN. So first of all, we need to understand what is a LAN network. LAN is a local area network, local in the sense um, which is within a room, within a house, within an office. So that is called a local area network. So switches are used in local area network. And for example, in this diagram, if you can see, there is a switch and there are two PC on this side, there is one PC on this side, and this is the printer. So overall, we can consider it as a local area network. It is locally connected through switches, and we we work at the MAC addresses layer, and if we need to talk to internet, then we need a router to connect to the internet. So in the first diagram, there is one switch, and the PCs they are directly connected to it. And there is another example for the local area network. Here we have an access point. Access point is like a Wi-Fi, and through Wi-Fi we are connected. So it's still, as we saw in our OSI layer model, physical layer. Wi-Fi is a physical layer as well. So through Wi-Fi we are connected to access point, which is connected to switch. So if we have a bigger network where we cannot lay the Ethernet cable directly, we can connect through Wi-Fi. For example, tablets or mobile phone, we cannot connect Ethernet cable to the phones. So we have the option of Wi-Fi only. So there we can use the access point. So this is another type of architecture of Ethernet network. Now, for the big offices, big buildings, multi-story buildings, we have another kind of architecture, which is this one. So here we have like first floor, second floor, third floor, three-story building, and each building have access point, which is connected to the Wi-Fi. Each story have a switch. Wi-Fi is connected there, and PC they are connected there. So basically, uh, this is this is replica of this network on our left hand side. So in this design, we have a switch and an access point. So in buildings, we can use the same design on each and every floor. And then we have a distribution switch, which is this one. All the switches connected to this main switch, which is connected to the router to be connected to the internet. So just to summarize, Ethernet LAN network, it's a local area network where we use the switches as a central point to interconnect, and we have three different design for LAN network. The first one is one router and one switch. In the second design, we have one router, one switch, Plus, we have added an access point. This architecture, it supports mobile phones which have only Wi-Fi and which don't have Ethernet cables. And then the third design is multi-story design. So in this design as well, we are using access point, a switch, and router. And for different stories, we are just using multiple Wi-Fi and multiple switches. So this is the Ethernet LAN network. Here in this diagram, we will discuss about different cabling standards. First column tell the speed of the media, speed of the cable. For example, 10 MB, 100 MB, 1 gig, 10 gig, and okay, and 1 gig, 10 gig. Okay, it support 100 gig as well. So, and common name here we call this Ethernet. 100 MB we can call fast Ethernet, and these are gigas and 10 gig. And in this column, these are the standard name IEEE naming convention, 10 base T, 100 base T. So this is a commonly used naming convention as well. And we can use this name as well, 802.3. This is the same as 10 base T. And here the supported type of cables and the length, if it's a copper cable, then 100 meter only. Normally fiber cable, it support more length. Fiber, it is, you see, 5 kilometer, 5,000 meter. So fiber, it is taking media in the form of optical light. So hence it go for longer distance. Copper, it carries electrical signals which does not support longer distances. So for long distances, we have to use fiber optic cable. So just to illustrate, here we have one PC. It is connected to switch. So normally PC and switch, they are not that far. They are in the same room or same building. So we can use electrical cable, Ethernet cable here, and then switch one to switch to 200 meter. So we can use Ethernet cable, but over 100 meter, it is recommended to use optical fiber. So we are using fiber here, fiber here. So switch to switch, we are using fibers. PC to switch, we are using Ethernet cables. So this is a general standard as well to use the type of the cable depending upon the other devices. In this diagram, we will illustrate the different type of connectors. So if we see in this picture, this is RJ45. This is called Ethernet connector, and it goes into the Ethernet ports. This is called SFP, small form factor. It go into these ports. So there are different ports to plug SFPs. So SFP are pluggable pluggable connectors, whereas for Ethernet they are fixed. We cannot replace them. So for SFPs, some of the ports, if it it support 1 gig or 10 gig depending upon the SFP inserted. SFP plus is for 10 gig. Same port, if we insert SFP, it will support 1 gig, and if we insert SFP plus, it will support 10 gig. We have two type of Ethernet cables: straight through cable and crossover cable. Rule of thumb is, if we have the same devices at both ends, switch to switch, we will use crossover. If the end devices, they are different, For example, this one is PC, this one is switch. We should use straight through cable. So thank you very much, guys. That's all for this lecture. Please subscribe to our Hi-Fi Tech channel and click on the bell icon button.